So this video is going to be like a little wrap up, more of like a Spark Notes version of everything we did in 6.3. We learned about component form and magnitude, so this just outlines the formulas that we use to find each of them. So when we are given 2 points, we can turn it into a vector by taking the terminal minus initial, and it'll always tell you what the terminal and what the initial points are. So it'll say which one's the terminal, which one's the initial. And then just like we said in the notes, the first point always goes with the first one, the second point always goes with the second one. So you just take your terminal minus initial for the x's, and then terminal minus initial for the y's. Super important that it's always terminal minus initial. And then we always represent our vector by the arrows instead of parentheses, and it's still separated by a comma. So vectors will have the little pointy brackets instead of parentheses. So if we had something like this that was given to us in parentheses, we know that that's a point. If we have something given to us like this is a vector. Now the difference between a point and a vector is a point is just a point on our graph. A vector is something that has length and direction. Now this brings us into the magnitude, which is just the length of our vector. If we were given 2 points, we can always just plug it in to the distance formula to find what our magnitude is. Or if we're given 2 points, we can find the component form and then use this formula, which is just a little bit easier. So if we had vector with a and, well, it gives us a and b, so let's say v1 and v2, whatever numbers these are, we just take the square root of v1 squared plus v2 squared. So just the first value squared plus the second value, and you square root it. This gives you the length of your vector, which is the magnitude. And again, we write the magnitude with the double bars. One thing that we didn't go over in the notes is our linear combination of vectors. So linear combination is just a different way of writing our vector, and it's written with i's and j's. So i's tell us how we move horizontally, the j's tell us how we move vertically. So it's the same way as our vector would be. If we had, let's say for example, 5i plus 2j, in component form, our vector would be 5, 2. So we just take the coefficients of each. Again, if we had I minus 3j, our coefficient in front of I would just be 1, so this would be 1, and then we keep the negative with the 3, so negative 3. So these would just be the component form if our vector was given to us as a linear combination. So looking at our example, it says the initial and terminal points of a vector are given. Write the vector as a linear combination of the standard unit vectors I and j. So first we have to find the component form, and then we can just tack on the I and the j. So for our component form, it's always terminal minus initial. So we take our first and our first, so 2 minus negative 1, and then terminal would be 6 minus initial, so minus negative 8. 2 minus negative 1 would be 3, because this becomes a plus. 6 minus negative 8 would be 14. So this would be in component form, but to write it as a linear combination, we put our I and j with it. So this would be 3i plus 14j. For our next example, it says find the component form of vector v, where u is equal to 2i minus j, and w is equal to I plus 2j, and v is u plus 2w. So first I want to change these into component form, just to get rid of those i's and j's. So we have 2, negative 1, and then for w it would be 1, 2. And then we just have to do whatever math it tells us to do to find v. So we have vector u, which is 2 -1 plus 2 times vector w, 1, 2. So first thing we want to do is distribute this 2 to everything behind it. So we have 2, 4, and then we just add our 2 vectors together. So when in component form, again, we just keep our first with our first, second with the second. And we're adding, so 2 plus 2 is 4, -1 plus 4 would be 3. And for this one, it asks us to keep it in component form. We don't have to put it back into the i's and j's, so this would be our answer. So just a reminder, this is our component form. This is our linear combination form. So just make sure you understand which one the question's asking you for, and that's how you'll have to type in your answer into WebAssign.